Hey everyone, so in this video we are going to show you how to add some additional items to the game world. In the last video we created a grass block and then instantiated it a bunch of times to create a grassy plain. Now I'm going to add some objects to those grassy plains, namely a crystal, a tree, and a rock. You also notice this area is probably a little bit neater. That's because I created a folder and I just moved the models in here. So not the prefabs, we have the prefabs out here, but we put the models in the corresponding material file and corresponding PNG file as well. So what we're going to do, let's go ahead and turn these models into prefabs. So let's go ahead and drag the crystal into the scene, and the same process. We're going to unpack prefab, separate, delete, and then rename, and we'll call this crystal. And we do add, physics, block collider. And when you're making your objects, remember you're using a three-dimensional grid, so you want to be mindful of that. So I created all these objects with the same base of 40 by 40. The vertical might be different, but the base is 40 by 40. That way they line up cleanly on a grid. So we then take that, put it into the scene, and then we can take the crystal and put it into the model. And now we delete the one from the scene. And I think I said it wrong again. I keep saying this is the scene down here. This is the asset area. I'm so sorry. I don't know why I keep saying that. So rinse and repeat. Pine tree, unpack, expand, drag and drop, delete, rename, pine tree. Physics, box collider. Now this one I did actually make exactly 120 vertical. So this is 3 blocks vertical. This one and this one I did not though. So we're not really too worried about verticality, but we do want to maintain at least the two-dimensional, the base of the grid. And then we can just drag and drop that into the asset area, delete it from the scene, and then put the model into the model folder. One more time, rock, unpack, expand, separate, delete, rename, rock, add, physics, box collider, put into the asset area, delete, and then move the model and leave the prefab. Great, so let's now make the GM object aware of these. So just as the GM object is aware of this block, we need to make it aware of these objects so we can use the same world build script. So let's go to our script. So here's world build, and we're going to add public transform, and this will be pine tree, public transform, rock, public transform, crystal. We'll save that. We'll briefly come back here just to create the linkages. So we click on GM. It compiles, and there's the new transforms. So pine tree to pine tree, crystal to crystal, rock to rock. Okay, so let's go back to our script now. So now what we're going to need, we're going to add a variable. And this can be private, because we don't need it to be accessible in the inspector. So private is going to be an int, and it's going to be spawn chance. So this variable is going to be used to hold a random number, and based on that random number, we will determine if an object gets spawned on top of a block. So first thing, give yourself a little bit more room. So let's make this like negative 48. We're just going to make a larger plane. Positive 48. And let's bump this up to like 60. save that. And now, so as we said, this is where the block gets instantiated. So we have an X position, we have a Z position. So no sense reinventing the wheel. Let's just use those positions right now. Just piggyback off of this to decide if something should be spawned on top of this block. So spawn chance equals random. Let's try that again. Random dot range. And now you put in the range. So we're going to do 1 to 21. Now here's the thing. This is inclusive, this is not. So the 1 can be a result, the 21 will never be a result. So if you want 1 to 20, you have to put 1 to 21. Now, unlike these numbers that are changing, this isn't going to actually be integrated into the placement. This is just going to be used as a random chance. So like rolling a die, so a 20-sided die. So if. Now, since this is going to be a grassy plain, we don't want there to be too much of a concentration. So part of this range, we're not going to do anything. So say 1 through 8, we won't do anything. So if it's above 8, then we do something. So if spawn chance is greater than 8 and spawn chance is less than, say, 12. There'll be a few trees. And we'll just take this. And it's not going to be the G block, it's going to be the pine tree. Actually, let's get rid of these extra spaces. It's bothering me for some reason. And it will be the pine tree's rotation. Now, I don't think I mentioned it. If I did, sorry for repeating myself. I actually have done this in a few takes. We're going to have to change the Y position because what happens is when you're using Magic of Voxel, for some reason, the origin point, so the point that's being used for the placement of an object, is actually below the object. I'll show you when we get back to Unity. So since it's below the object, we have to push the object up to get it to where we want it to be. So what we're going to do, I don't know the exact number, so this is just going to be a bit of a guess, and we can always adjust it. Okay, but that's specific to Magic of Voxel. If you're using like Rocket 3F, I believe you can actually choose where the origin is, and if you're using Blender, I think it might default to the middle. I'm not certain. But we'll look at that in just a minute. So we'll save that. So let's now copy this whole thing and just tweak a few numbers. So we now have greater than 8 and less than 12. So that means we need greater than 11, since 12 is not accounted for yet. And we'll say less than 14. So that's only 12 and 13, so let's say less than 16. And this will be, let's have this be rock. And rock. And offhand, I don't recall if the distance for the origin varies per object. I'm not sure if it's based on size or not, so we might have to come up with different Y positions. And then lastly, we only want there to be a few crystals, so 16 is not accounted for. So if it's greater than 15 and less than, say, 18, and we just won't include 19 or 20. So 19, 20 would just like 1 through 8 would result in the spawning of nothing on top of the block. And we change this to crystal. And we change this to crystal. And let's see how that looks. Okay, so crystal is not high enough, and I think the rock is kind of cut off too. The tree looks okay. It also depends on the perspective. I can actually see most of the trunk, so I think that the tree is okay, but I could tell that the crystal is definitely cut off. So let's go ahead and change those briefly. So we need them to be a little bit higher. So let's try 3.5. And if you're using a decimal, you have to drop in an F. I believe that stands for float, or else it confuses the system. Yeah, better, but not right. So let's go up to 4. Yeah, that's pretty close. I think they're actually, yeah, I don't think anything is cut off. Now, way more populated than what I wanted. If we're looking for plains, we kind of failed. This is actually more like a medium forest and probably a few too many rocks. Crystals, that's totally subjective as well as the rocks. But if we wanted this to be more of a plainsy area, then let's just do this one more time and then we can move on to the next topic. Unfortunately, we have to kind of shove all these numbers over. So if it's, say, greater than 10, so we move that by 2, but we'll only move this by 1. And if this is greater than 12, and we won't move the upper limit because we said we want less of these too. And if this is, so that's less than 16. So since I didn't change that one, I don't need to change this one, but I need to change this one because again, we're trying to reduce how many there are. Okay, that's definitely better. It's definitely much thinner. I'm not going to mess around with it anymore because I think you get the idea that you can make certain objects spawn more often than others. And so as you can see, you have lots of places where absolutely nothing spawned on top of the block. And then the trees and the rocks, they look a little bit more balanced than what I was trying. I kind of wanted it to be less rocks, but that's for you to experiment with, to try to make it balanced to the way you want it. So now that we have a range of objects, we can start looking at gathering from these objects. And essentially what you're going to do, you're just going to have variables, and each variable will represent a different resource. So you would have a variable for dirt, you'd have a variable for crystals, for wood, for stone, that kind of thing. So let's go ahead and create, let's click on right click, choose create, choose C# script, and we'll call this harvest. And what we'll do, we'll click on our 3 objects and we'll just drag and drop this script onto them. And then what we're going to do, since these don't have multiple versions, now if you want, you can take the same approach. Have 3 versions or 4 versions, excuse me, to have 4 versions of each one. But if maybe for aesthetic reasons you don't want to, or for developmental reasons you don't want to, like you don't want to go through that much design, maybe you want a smaller application, whatever your reasons are, I'll show you another way to do this without the visual destruction. You could just create a variable that tracks hit points. All right, so let's go ahead and open up Harvest. Again, you can delete this. Delete this. Those are just non-executed remark statements. And we will say public. This will be, we'll use, let's use a float instead of an int. So public float, and this will just be obj HP. So the object's hit point, and what happens is because it's public, we can set it independently so each object can have its own hit points. So if I click on this, a crystal, I can say, see object HP, I can say, well, a crystal is delicate, so maybe it only has 20 hit points. A rock is real durable, so maybe it has 60 hit points, and we'll put the tree in the middle. Again, I'm just pulling numbers out of thin air. You can do whatever you want. This is just for demonstrative purposes. So now whenever you click on this, you have to determine how much damage is done. So depending on what you do, as far as does your character have different tools, like they have a pickaxe or they have a regular axe or a chainsaw or a drill, then you're going to adjust how much damage gets done. As I said before, this is an iterative process. You have to put the basics in place. So we're not going to consider any of that. We're just going to consider that you could do the same amount of damage to any type of object when you hit it. So we're going to do something kind of similar to the block con. We're going to say on mouse down, and we're going to say obj8, whoops, let's try that again. Obj_HP minus equals, so whatever value it's equal to, subtract something from it, we'll say 10. And then we'll say if, rather than doing it, you don't want to do the if here because it checks it only when the mouse is down. So if something goes wrong, it will be missed. So we'll put this in the update section for now. So if obj_HP is less than 1, then destroy game object. We'll test this, make sure this works, and if it does, then we'll actually put in the variables that say you've got X amount of wood or X amount of crystal. Okay, so on mouse down, reduce HP. If HP is less than 1, destroy the object, and this should be attached to all objects. Okay. So crystal should be destroyed with 2 clicks. Yes. Rock should be destroyed with 6, was it? Yes. And this should be destroyed with 4. And then we already have this working. And actually, it doesn't hurt to, if you've added new functionality, it doesn't hurt to test old functionality and make sure you didn't break old functionality. So, okay, great. Now we just need to create the variables that will be incremented based on what you're harvesting. So we want to go back to, we can either put it into the world build, or if you want, what we can do, since this is going to eventually become a really large script, we can create a second script that's attached to the GM, really just for organizational purposes, that handle more game flow type of events. So let's do that. Right click, create C#. We'll call this game flow. And we'll use this for storing global static variables. So let's put that there. And yes, you can, as you just saw, you can add multiple scripts to one object. So again, we'll delete these, and we'll just start creating variables. So this will be, so public and static. We hadn't seen that yet in this series. Static is how you make a variable accessible throughout the entire application to all objects. It will only change if you expressly change the value. So even if you reload a level, your static variables do not change. You have to expressly change them. So public static, let's call this, sorry, I gotta say what kind of variable it is. Let's use floats. And some of these you might decide to go back and use ints. That's troubleshooting later down the line. I'm going to use floats for a couple of reasons. So public static float, and we're going to call this total, say, dirt. And it starts at 0. And when you're using a numeric variable, if you do not declare this, to the best of my knowledge, it defaults to 0. same if you're creating a string, so that's text, it will default to like null. There'll be no value to it. It'll be blank. So public static float, and this will be total crystal. Rinse and repeat. My apologies that I keep saying that, but so many times I'll show something and then someone says, I'll show someone how to do X, Y, and Z, and they're like, well, how do I do A, B, and C? It's like, it's the same thing, just again and again and again. So public static float total stone. Public static float total wood. Now, again, this first time around, we're going to have constants, so you're going to get a guaranteed amount. You're going to eventually want to add randomized statements and randomize how much people get. All right, so maybe there are skills that guarantee that you get more. Okay, maybe there's a 1 in a 10 chance of getting something special. Then you would do something similar to what we did with the word build, where you start using a variable to decide if something else is gotten, but that will be a separate video. So we have our 4 static variables. Now it's just a matter of adjusting these. Since these are static, these will be accessible everywhere. So in the update section, we're just going to put debug.log. Since we don't have like an inventory or anything like that, technically this is the beginning of an inventory. We just don't have it displayed in a user interface manner. So we're tracking the variables, which is not displaying them in any kind of accessible way. So what we're going to do is we're going to just display the values here. So total crystal, and then I believe it's plus space plus total dirt plus. So to be clear, I'm not adding these, I'm concatenating them, and that is I'm going to have the numbers listed after them so you can see them incrementing. Plus total stone plus total wood. Now, if I'm not in the script where these are declared, I can't just do total crystal, total dirt, total stone, total wood. I actually have to say where this is declared. So I'd have to put gameflow dot total crystal. So you're about to see that in a second. I just wanted to get ahead of that. So with every frame, this should get updated with the totals. And again, this is just putting a space between the variables. Otherwise, you just have the 4 numbers running next to each other. Okay, so we are now going to go to our harvest script, and this is where we said if it's less than 1 HP, destroy it. But now we're going to say before you destroy it, we want to increment the object. We want to increment one of the objects in your inventory based on what you just destroyed. So what we really need to do, we need to create more tags. We looked at that in the previous one. So let's do tag, add tag. And again, this doesn't attach the tag. This just creates it. You have to go back and add it. So we'll do crystal. Maybe in your game you're going to have blue, red, and yellow crystal. Obviously, you're going to have to differentiate those. So we're going to say crystal. We're going to say pine tree. And we're going to say rock. Now we come back and we do crystal, pine tree, rock. All right. Now, this one, because it has its own script, at least for the moment, you don't have to do that. You don't have to put a tag, okay? It has its own script. So what we're going to do here, so for harvest script, which is attached to, right now, the rock, the crystal, and the tree, we're going to say if game object dot tag equals, we said pine tree, then we want something to happen. Someone also mentioned in one of my previous videos that tag creates a lot of garbage and that it works, but apparently it creates bloat. So we will look at doing a more efficient later. But again, optimization, that's long term. You have a very basic process of prototyping, proof of concept, and then you can go back and optimize later. AAA games do that all the time. So if you see something that's less than efficient, I'll try to do like a video at the end specifically geared towards optimization and cleanup and getting rid of redundancy and things like that. So if GameObject.tag is equal to pine tree, then, so this is what I was saying, we have to declare where the variable is. It's in game flow, and it is total wood plus equals a certain amount. We'll say 10 because it's a tree. And now it's just rinse and repeat. And we just copy, paste, and let's go ahead and paste it a second time. And then we just have to make sure that we change the tag in the variable. So this will be rock is the tag we chose, and this was total stone. We'll also give it a different increment. We'll say stone is just 2. We'll change this one to crystal, and we'll change this to total crystal. And we'll make that like 5. And we'll do the blocks separate. That's going to take like an additional if statement to differentiate when something is the last block, but not too big of a deal. I just want to check this coding first. So let's run it. So there's the 4 variables. So if we click on a rock, I believe it was 6 times. There's the 2 rock. Tree 4 times. It's 10. And crystal twice. And it's the first one. Great. So let's just double check one thing. So dirt must have been the middle one. Yes, or the second one, I should say. Okay, so we said block count is going to be slightly different. And it's really not that different. Effectively, it's the same principle of this with checking the tag. In fact, let's just do that. Let's not make a big deal out of this. So we'll say if game object dot tag is equal to last block. So this checks to see if it isn't equal to. This will check to see if it is equal to. And I suppose we could just do an else statement, which would be part of the optimization. But again, I kind of like spelling out the logic when I first demonstrate how this works. And this will just be total dirt. And we'll say 15. So we run, and let's see, so rock populated, let's do crystal. Again, making sure we didn't break something that we already put into the game. And then the dirt should be the middle one. Now, if you notice the way this is working, you don't get the resource until the unit breaks. So depending on the game, sometimes you get some resources as it's being broken. That's another layer of complexity. We can look at that in another video. Again, getting the basics in first. Okay, I think that's actually good for this video. We now have the ability to spawn not just the ground, but several things on top of the ground. we now have the beginning of an inventory system. Even though it's just variables, that is at its core what an inventory is. It's just a matter of displaying that inventory in a way that's easily accessible. Like you have a UI and you have an image that corresponds to each number. So we have total stone. Well, we need to have an image of a stone. Total dirt, we need a pile of dirt, so on and so forth. So it's not just having variables, it then has a visual depiction of those variables. Old school games probably wouldn't. Old school game might just have the word stone and then a number, dirt and then a number. Again, it's completely subjective. It's what you want to do. So at some point, you're going to take what I've presented and then build on it and deviate from it. And hopefully that this a decent amount of this series will be meaningful to you and helpful to you. So I think we'll end this video here. In the next video, I think we will now add player movement. And so we'll actually either make the player first as, you know, the little like Minecraft blocky character, or we'll just put a first-person controller. I'll make that decision when we get into the next video. So that should about do it. I hope you found this helpful. If there's any features you want to see, please put it into the comments. Someone says that they want chunks. So I just want to mention, so to the best of my knowledge, Minecraft is broken down into what's known as a chunk, and it's a certain size, horizontal, vertical, depth. It's a certain size. You could argue that the world build, you could say that this is a chunk, because even though we've made this to be like a monolith, like a single set of things that execute from top to bottom, you could always turn this into like a subroutine. Don't let that confuse you. We'll talk about subroutines in a later video, but you could have a standardized size and have so you could have a subroutine called spawn forest, spawn lake, spawn mountain, whatever. And it would be of the same size. That would create a chunk. So I believe that's what the commenter was referring to. So yeah, you could basically have a consistent amount of area covered. That would be a chunk. Okay, so again, hope you found this helpful, and please enjoy the rest of your day.